Hello, Geometry Cherubs. Welcome to the Area Project. This is the first video. Today we're going to be talking about the area of parallelograms, and we're going to link it to something you've already learned before you even met me. So I'm sure you've already learned about how to find the area of a rectangle. Area of a rectangle is base times height. But what you might not have known yet is that the reason that formula works is because in a rectangle, special parallelogram, those angles are all right angles, and so this base and height are perpendicular to each other. Now the formula for the parallelogram is exactly the same, but the meaning has to be understood that a base and a height are perpendicular to each other. So for the whole area unit, whenever we talk about the base length of a side length and the height, you have to know that those two lengths must be perpendicular to each other. And so in order to find the base and the height for the parallelogram, it's a little more challenging than just taking the sides, because in a regular parallelogram, the sides are not perpendicular. So when you look at the situation in a parallelogram, we have to remember opposite sides are congruent, 15, 15, 20, 20. And so but if we want to say which side, we can use any side length to be the length of our base. And you strategically choose it depending on what you're given. In this case, I see the height, 12, is perpendicular to the base 20. So this is my height and this is my base for this problem. And I can calculate the area by using that base and that height. On the other hand, in this diagram, I have to use the knowledge that because it's a parallelogram, I know that in a parallelogram, opposite sides are congruent. So I know that this side will also be 4.7 inches long. And because of that, I see that this base and this height are perpendicular to each other. Notice I know this length is 6, but I don't know the height that is perpendicular to it. So I can't use that for this problem. So I have to use what I'm given. Because it's a parallelogram, opposite sides are congruent, and so I use my base 4.7 and the height perpendicular to it as 5.7. And now I can calculate the area of that yellow parallelogram. So pause, find the area, and then press play. I need a base and a height that are perpendicular. So for this problem, I'll use 5 times 4 and get my area. Now let's look at that same parallelogram. What if I wanted to rotate it so that this side was my base, so that I could calculate the other height in the other direction? If I wanted to do that, my strategy would be to use the area that I've already calculated, 5 times 4, 20 square inches, and then use that knowledge and the same formula, because the area will not change when I rotate it in space. So if I rotate it, the area is still going to be 20, but that area is going to be base times height in the other direction. So this area, 20, also equals 4.5 times the other h. And I can solve that for the other height by dividing both sides by 4.5. So in chapter 4, we learned that what an altitude is, and sometimes we have to extend the opposite side to drop down the altitude, and that happens when the angle is obtuse. So notice for this yellow parallelogram, in order to find the height in this direction, we had to extend the side. Now when we extend the side, that's imaginary, that's not part of the base length. So when we go to find the area of this yellow parallelogram, the formula, remember, is base times height, 2 times 3.5. Okay, so pause, calculate the area of the yellow parallelogram, and then press play. I use the fact that it's a parallelogram, so opposite sides are congruent, and this base extends to go with this height. And that's how I can calculate my final area. Oops, square units. So now pause the video and calculate what this height is, and then press play. First step, I have to find the area of the parallelogram using the height and base that I'm given. And I see that this base goes with this height, so I can find the area of my parallelogram. Once I know the area of my parallelogram, I can then rotate it and use the same formula to figure out what the other height would be. Pause, find the height, and then press play for the solution. First, I'm going to find the area with the information that I do have, and then I will know that 10 times h equals the same area. I have to use my knowledge that opposite sides of a parallelogram are congruent, so my base and my height, 14 and 8, will allow me to calculate the area, and now I can rotate that parallelogram in space to make this the base and this the height. And then I can solve for that height. Pause, find h, and then press play for the solution. Next, find the parallelogram problems in your packet, complete those, and there's also a matching Math Excel assignment from Math Excel for School. And as always, if you need any help with any of these problems, let me know.